Visit Chandra's beautiful universe. Intermediate mass black holes. In some of the most crowded parts of the universe, black holes may be tearing apart thousands of stars and using their remains to pack on weight. This discovery, made with NASA's Chandra X-ray Observatory, could help answer key questions about an elusive class of black holes. While astronomers have previously found many examples of black holes tearing stars apart, little evidence has been seen for destruction on such a large scale. This kind of stellar demolition could explain how mid-sized black holes are made through the runaway growth of a much smaller black hole. Astronomers have made detailed studies of two distinct classes of black holes. The smaller variety are stellar mass black holes that typically weigh 5 to 30 times the mass of the Sun. On the other end of the spectrum are the supermassive black holes that live in the middle of most large galaxies, which weigh millions or even billions of solar masses. In recent years, there has also been evidence that an in-between class, called intermediate mass black holes, exists. The latest study, using Chandra data of dense star clusters in the centers of 108 galaxies, provides evidence about where these mid-sized black holes might form and how they grow. Because stars are so close together like they are in these extremely dense clusters, it provides a viable breeding ground for intermediate mass black holes, and it seems that the denser the star cluster, the more likely it is to contain a growing black hole. Theoretical work by the team implies that if the density of stars in a cluster, the number packed into a given volume, is above a threshold value, a stellar mass black hole at the center of the cluster will undergo rapid growth as it pulls in, shreds, and ingests the abundant stars in close proximity. Of the clusters in the new Chandra study, the ones with density above this threshold were about twice as likely to contain a growing black hole as the ones below the density threshold. The density threshold depends also on how quickly the stars in the clusters are moving. The process suggested by the latest Chandra study can occur at any time in the universe's history, implying that intermediate mass black holes can form billions of years after the Big Bang, right up to the present day. While the latest study doesn't prove that runaway black hole growth occurs in star clusters, it lays the groundwork for additional X-ray observations and extra theoretical modeling to construct an even stronger case.